involved in there. Is that right? As the block slides down the inclined plane, the component of the force pulling the object down the plane, what is that component? mg sine theta. Well, that does work, and the frictional force is acting up the plane, and that force also does work. If one work is positive, the other work will be negative. Now remember, work done is not a vector quantity, but if the work done by a force acting in this direction can be considered positive, the work done by a force in the opposite direction will be considered negative. So in this case, work is done by two forces, and we are required to find the net work done. Now here is the object sliding down the inclined plane. When the block slides down the inclined plane, the frictional force acts up the plane. Now, do you remember the equation for the frictional force? The frictional force is mu times Fn, the normal force. And the normal force in this case is mg cos theta. Therefore, the force of kinetic friction. Why is this the force of kinetic friction? Because the object is sliding down the plane. The force of kinetic friction is mu k mg cos theta. Now the force of kinetic friction between the block and the plane is Fk equal to mu k mg cos theta. And that will be mu k is given 0.275, m is 3 kilogram, g we know, and the angle is 20 degrees, so that will be 7.6 Newton. The frictional force acting up the plane is 7.6 Newton. Alright, there I have a frictional force is 7.6 Newton. The force F pulling the block down the plane is mg sine theta. M is 3 kilogram times g times sine of the angle, and that will be 10.1 Newton. So the force pulling down the plane is 10.1 Newton. Alright, if the work done by the force pulling the block down the plane is positive, then the work done by the friction acting up the plane is negative. That concept we'll be using as we go on. If work done by a force in the positive direction is positive, the work done by a force in the negative direction will then be negative. So, work done by the force pulling the box down the plane is the force down the plane, that is 10.1 Newton, times the displacement. Now, what is the displacement? The object is going to slide down the entire length of the plane, and we are told that the length of the plane is 1.5 meter. So, force multiplied by displacement in the direction of that force, and that will be 15.15 joules. What is the work done by the frictional force? It will be negative 7.6. Because we use 10.1 positive, we will use 7.6 negative. Negative 7.6 Newton multiplied by the same displacement. Displacement is the same in both cases. That will be negative 11.4 joules. And so what is the net work done? The net work done is 15.15 minus 11.4, that is 3.75 joules. And that is a measure of the net work done in that case. Okay, another problem. A father pulls his young daughter on a sled with a constant velocity on a level surface through a distance of 10 meters. If the total mass of the sled and the girl is 35 kilograms and the coefficient of kinetic friction between the sled runners and the snow is 0.25, how much work does the father do? If the force applied makes an angle of 30 degrees with the horizontal. Well, once you picture that problem, it actually becomes simple. We don't know the force applied by the father on the sled, so we may have to figure that out first before we can find out the work done. Is that right? Okay. Now, if you want to picture this problem, here is the sled and this is the snow, and the father is pulling the sled like this at an angle. We know the angle. Now tell me, what are the two forces here? Well, this force makes an angle theta with the horizontal. It has a horizontal component F cos theta, and that F cos theta is the force that does useful work. And it has a vertical component F sin theta. Tell me, what does that F sin theta do here? Now, when you want to measure the frictional force between the two surfaces, what is the equation for the frictional force? Well, the frictional force, the frictional force will be Fk equal to mu k Fn. Is that right? The frictional force Fk equal to mu k Fn. Fn is the normal force. That means when the father pulls the child with a force like this, the vertical component of this force actually reduces the normal force. You see, the normal force is the force that is pressing the sled onto the surface. Now, the force that is acting down the plane is mg, is that right? That is pressing the two together. And when the father pulls the sled like this, the component F sin theta is up the plane like this. That means the normal force Fn is now mg minus F sin theta. So there is an advantage in pulling the child like this rather than pulling it horizontal. What is the advantage? By providing a normal component of this force, we are reducing this normal force that presses the two surfaces together, thereby reducing the frictional force. Alright? We will be using this concept to solve this problem. So you must understand that concept well. Okay. Let's now draw a diagram. Here is the sled. Well, it's a very cute sled though. The sled is pulled with a constant velocity. What does that mean? It is pulled with a constant velocity. There is no net force on the sled. Now, the weight of the sled and the child is, the total mass is given to be 35 kilograms. Therefore, the weight is mg, 35 kilogram times 9.8 meter per second squared, is 343 Newton, which will be acting down the plane, and that is the force that presses the sled and the child to the snow. The force F applied by the father makes an angle 30 degrees with the direction of displacement. So F makes an angle 30 degrees with the direction of displacement. What does that mean? It means the component of this force in the direction of displacement is F cos 30 degrees. Now, using the value of cos 30 degrees, that will be 0.87 F. That is the force that is actually acting in the direction of displacement. F cos 30 degrees is 0.7 F. And the component of F at right angles to the displacement is F sine 30 degrees, that is 0.5 F. This is the normal component or the vertical component of this force. That will be 0.5 F. The net force pressing the sled to the floor. Therefore, the net force pressing the sled to the floor is 343 minus 0.5 F. And this is a measure of the normal force between the sled and the ice. Therefore, Fn equal to 343 minus 0.5 F. The force of kinetic friction Fk acts opposite to the displacement. Is that right? Force of kinetic, if the displacement is to the right, the force of kinetic friction is to the left. And what is the equation for that force? Fk equal to mu k Fn. Mu k is given to be 0.25 and Fn is 343 minus 0.5 F. Well, we have said earlier that the forces on the sled are balanced because the sled is being pulled by a constant velocity. What that means is the Fk acting to the left, this Fk, which is mu k Fn, given by this quantity, is exactly equal to 0.87 F. You see that? Now, if you can now take these two and equate them, we can calculate that F. That is a strategy of this problem. So once again, when the sled is pulled with a constant velocity, the net force on it is 0. That means the force acting to the right, 0.87 F, minus the force acting to the left, which is mu k Fn, and which is this quantity, that must be equal to 0, or this quantity, 0.87 F, must be equal to the frictional force. Now, since there is no net force on the sled, 0.87 F Newton pulling the sled forward is balanced by Fk, which is this quantity. So I can now take this quantity Fk and set it equal to 0.87 F, and you can see we got an equation that contains only one variable, that is F. Solve for F, distribute and combine the terms in F and solve. You get F equal to 86.2 Newton. The force applied by the father is now 86.2 Newton. We can now find the work done. The displacement is 10 meter. Therefore, what is the work done? The work done is, work is done by this force, 0.87 F. F cos 30 degrees multiplied by the displacement. That is 0.87 F multiplied by 10. And that will be 0.87 times F equal to 86.2 Newton. The displacement is 10 meter, and therefore the work done by the father is 750 joules. Now this is a good problem, and it's good to know the method of solving problems like this.